Okay, in this session we're going to cover how to practice soldering a strain gauge on. Now I want to point out this is very different than the soldering lab where you're doing the little circuit boards and getting certified for soldering upstairs. These little strain gauges that we're dealing with right here are very sensitive to the heat, and we have to really minimize the amount of heat that we put in that. So we're talking about very fine amount of solder and heat going into this so we don't damage this. And we're going to be talking about how to prove that we didn't damage that later on as we do the final install. So this is practice. Before we give you this final strain gauge, you need to prove to the TA that you can tint and that you can also solder on the wires correctly, repetitively, and then we will give you the strain gauge and you can mount that strain gauge. So what we're doing is trying to keep our costs down and also allow you to have maximum practice at soldering, especially in your group. We want the maximum number of people, so the TA is going to give you a piece of this foil tape right here. Now try not to bend this around. You notice it's nice and pretty and looks like copper, and it is copper, and it has an adhesive layer on the back. And what we're going to do is take our tweezers back here and slowly pull that copper off right there from the adhesive backing. Okay, and what we're going to do is come in here and lay that onto this structure right here. And you notice I'm just going to put that on there. And now I have copper onto this material. What I find is this is a great way to simulate the actual encapsulated strain gauges that we're dealing here, trying to solder on to these little pads on these gauges. So it's fairly close to what you're doing. So it's not like we're having to practice and learn with your one-time shot that we give you one gauge. We want to have a lot of practice time here. So let's get competent in doing this. Now let's talk about the equipment we have at hand here for this. And I'm going to kind of use the just-in-time approach of learning the equipment as we go. Let's talk about our one piece of equipment that's going to do the major heat generation. This is our Weller soldering unit. We have an on and off switch here. You can turn it on, and it's going to be set to about 650 degrees Fahrenheit. I find that's about what we like working on here. If we decide to change that, we'll put a notice in the lab sheet. So in the video right now, we're going to ramp up to 650, and you see it's ramping up fairly quick. Now, let's talk why it's ramping up here about this torch, the tip of the tool here that's going to get hot. I've got the scissors out here with the red piece. From right here to here, this is going to be hot, guys. This will burn you. We're up at over 500 degrees there right now. And so you don't want to touch that. You only want to hold the tool back here by the foam portion on here. Don't be touching the wires and touching other things or touching your buddy. Put the tool back over here in its holster when you're not using it. So we're going to pull this out, and we're going to use this at this point. Now what happens is this torch, or the tip of this tool, is going to become really, really hot, and it's going to get contaminated. You can see there's some charring and burning of the material down here. And to help prevent that, this unit will basically, after so many minutes, will ramp back down to 360 degrees Fahrenheit. If it does that, just reach up here and push the up arrow, and it will ramp back up to 650 really quick. Okay, so what I'm going to do is come in here and clean the end of that tip. You saw it was kind of dirty there, and now it's clean. What I need to do is put some solder on here, and I want to watch what happens. I'm going to put a little bit of solder on here. Oh, that smoke's going everywhere. That brings us to the next point of equipment that you need to have. I need to have this fan up here where I'm going to solder, and I'm going to put some more solder on there and make some more smoke. Now look where my smoke goes, right into that fan, not into my lungs. So be sure that you're doing that correctly, that you have the smoke going into that filter as we're doing this. Now then, let's talk about our solder that we're working with. Working with a tin lead solder, 60% tin, 40% lead. This one, I have two different sizes of solder here. This is the standard solder wire that we use upstairs for soldering our circuit boards, and it's 0.8 millimeters. In the inch system, that's about 32 thousandths, so 0.032. I like working in the inch system for some reason. My preference is going down to the same alloy, eutectic alloy, but I like going to a 22 thousandths diameter, so it's 10 thousandths, just a little bit smaller wire than the thicker wire. And I will use this when I'm actually soldering the strain gauges. Where do I use this thicker wire? When I am doing things like tinting, and we'll talk about tinting, what that is, the wires themselves outside of the strain gauge. So I find that I like to have both because this 22 is really not going to put much solder out there compared to the larger wire. So the next thing we want to do is talk about tinting. What is tinting going to do? It's going to prep the surface for the soldering. So what we're going to do is we're going to have a wire that we're going to want to tint on this. Now this copper strip is going to simulate the strain gauges. You notice I put this strip on here in a certain orientation. I put the strip, let me do this with the backing, I ran it this up and down here. If I was going to bend this beam, I would want to put my gauge on here, and if you guys remember, we talked about the strain gauges, that you have the grid line, and we have a mark that we could line up with the burnish line, and this was going to be designed to be running this way, the strains, measuring it in that direction, so I can see the elongation of the compression of that grid. So what I'm going to do is imagine having several pads along this tape right here so that I can practice a whole bunch. And if you need another piece of tape, just ask the TA, they'll get you another piece. If I had this copper piece done on this way, then I'd be soldering this way, and it would be a little bit different than what I'm going to be doing when I actually do my lab. So put the tape on this way. And the next thing we want to talk about is the fact that the strain gauges we're going to use are encapsulated, but they have these little pads. Typically what we like to do is cover about 25% to 30% of that pad with tape. Now we have two different kinds of tapes here. This tape over here, this tape is used for super gluing the gauges on, not for soldering. We're going to have either painter's tape or drafting masking tape or something of that nature like this. And we're going to take that tape, and I'm going to put that tape right across that copper portion there. Now what am I simulating? I'll show you what I'm simulating. I'm going to put that onto my pad right here. I'm going to cover up about 25% of that pad if it was laying down there, so that I don't get the heat into the gauge and damage it. All right. Now you're going to notice we're using a lot of blue tape here, or masking tape. What I recommend doing is, you know you're going to use some, just put some pieces up here, because you're not going to want to have to depend on your partner as much. They're watching and learning, or they may be busy, because we have multiple stations for you guys in your group, and so you'll probably have 2 stations per group working on this at the same time. Now I have this prepped. I'm going to imagine that there's little pads all along there that I'm going to come in there and solder onto. Now I'm at temperature. I'm going to clean the tip of my iron off. I'm going to use the wrong wire. I'm going to use the thicker wire, and I'm going to come in here and tint my tip, okay, and then I'm going to put the solder down, and then I'm going to push that down. Now that just made a nice little solder piece on the pad there. That's fairly large, okay. I'm going to bring that up to the camera and show you guys that that is fairly large. I'm going to make a smaller one. So what I'm going to do, I'm going to change wire to the 22 thousandths diameter wire, still at temperature there. I'm going to come in here and tint my tip. I'm going to put the wire underneath, and if I do this, I made a little bit size difference. That's still a little large for my taste of tinting the pad. Okay. Now I'm also away from that tape, so I want to practice getting close to that tape so I can act like I would have a wire that would be put on here and soldered. Okay, because I would probably want to come in here and remove the insulation back a little bit and practice doing this. So what I'm going to do is practice several times with a thinner wire till I can get some really nice tinting going on closer. And again, I'm going to move everything up here to this fan. I'm going to tint my iron. I'm going to come in here and put a little bit there. Okay, so let me pull this up here, and if we look at this, I have several different tintings going on here. I was really big, medium, and then I got 2 smaller tintings down here. I don't need to do anything much bigger. I just need them fairly small, because the wire that we're going to put out there on that is only going to be about 1/16 of an inch exposed on the end. Okay, so let's talk about this wire now. What I have is 2 tools to cut this wire. One is the nippers. So be careful doing this. This is going to be nice. If I nip this wire right here and I cut this off, this wire is going to shoot out this way. So if I'm nipping something, a lot of times I like to nip it downward so that it shoots away from anybody and down into the table or down below. And so I'll nip this, and you'll see that sometimes it will stick, sometimes it will shoot off. So just be prepared for safety in cutting our wire. Now this is great for cutting wires to length. Doing this example, I may start with just a 2-inch diameter piece of wire because it's going to be easier for me to handle and show, and I can do several of these, and we can keep using this up till it gets down to about nothing, till it's about 1 inch or less. And what we're going to do is we're going to come in here and attach several wires and show the TA that you're competent in soldering these wires on. So the next tool we want to talk about is our stripper. Now this stripper is spring closed. Yes, it looks like you could cut the wire down here, but these are not cutters. The strippers are in this grooved portion, and it's set right here to close at a certain gap. So don't really grip down on this and try and distort the tool. Just put it on there and come in, close it, and then pull the wire off, and you'll see that exposed wire right there. We don't want to cut the wire or nick it. We want the wire where it's going to be nice clean wire minus the insulation. The next thing I'm going to do is I'm going to pinch this and I'm going to rotate my hand this way, and I'm going to twist that and put some nice twist on there. This wire is braided wire. Okay, so now we're ready to come in here and tint this wire. Got a good zoom in on this. And again, I've got my iron up to 650. I'm going to clean it, tint the wire. Now this is the thicker wire, soldering wire. This is the 8.8 millimeter, the 32 thousandths diameter. I'm going to come in here and just put this on here, and I'm just going to let that solder flow into that wire there. Okay, I've basically put solder inside that braided area. What I find, this makes it a lot easier for soldering the strain gauge on and reducing the amount of heat that I put into the strain gauge. And basically I can just let the solder from this wire and the pad flow into each other, and I'm there. I don't need to put a ton of heat on this. So we have these pads here, and what we want to do is I'm going to use the same tape here. I'm going to pre-bend my wire down like that. You guys see I'm getting a nice bend in my wire? Or let's do that. Let's go ahead and bend that wire down right there. Okay. What I'm going to do is take this tape and I'm going to put it right here on the back, if I can get it there, where the bend is down. I'm going to take that tape and bend it down onto the wire. I've got the tape applied where it's following the bend, and I've got a little bit of exposed insulation there. What that's going to do is I'm going to set this on here. Now first of all, that wire is too long. I need to trim that. The wire length that you need to have is 1/16 of an inch or less. Okay, so I'm going to put this up here. And again, that's going to shoot that little piece off potentially. I'm going to shoot it down, and I now have about 1/16 of an inch of wire sticking out. That's a very small amount of wire. I've got that nice bend in there, and when I put this on the one that I want to solder to, if I come in here and do this correctly, and I tape that down, that is going to take that wire, that the wire that's bent, and I had the tape up here, it's going to put force down onto that pad. Now if you need to move stuff around, you do have a pair of tweezers that you can come in here, and I'm going to move this around just a little bit and get it set exactly where I want it, so that I have the wire on the pad not extending over where the strain gauge is going to be, or I'm not going to let the metal of the wire touch the base metal down here. Okay, yes, I've got extra copper on here, but I just want to practice soldering right now. So what I'm going to do is, I'm still at 650. I'm going to take my thinner wire. I'm going to come in here and tint this. Okay, you can see that. I'm going to put the wire on top, and I'm just going to flow 1, 2, that wire, and the solder from the wire and the solder of the pad are going to flow together, and they are now going to be one. And so if I look at that, that's a nice little discrete solder joint that if I pull this tape off, and a lot of times I hold this, when I do this I don't pull the tab up, that wire is now soldered onto there really, really good. And what you need to do is practice soldering wires on to about 3 or 4 of these pads successfully, so that the TA can inspect your work. And once you get this mastered, then we're going to move you on to the next stage of soldering your strain gauge. Okay, in this session we're going to be prepping the part for a strain gauge. Now we're going to do this in an approved area. For the strengths lab, we have this wood table set up with a vise and all of our supplies for this. Only do what we're doing in this section right here of prepping the surface of wet abrading, dry abrading, and all that kind of stuff at this area. The reason being, if I wipe this table, you're going to see that the table is very dirty. I've got a lot of oxides, a lot of powders and dust on here. We'll clean this up at the end of the lab, but I don't want this contaminant going over where we're going to mount the strain gauges and solder them on. So let's keep this our dirty area, and let's go to town on this thing. So what we're going to do is mount our strain gauge. Now these are in a Mylar packet right now, so it's safe for me to show this. I'm going to mount that gauge about right there, okay, in the center of the beam, be in the center in this direction vertically here. So to do that, I need to remove all the grease on this material. So we're going to start with simple green. So you might be lucky and find a nice bottle of simple green here at this station, or you may find it in a little pump bottle like this that I can come in and clean that. Now if I'm going to use a little pump bottle, I'm just going to take a rag like this. I'm going to get it wet, and I'm going to come in here and I'm going to clean this part. You notice I'm only wanting the gauge here, but I'm cleaning a very large area. That's okay. I want to get all that grease off that part. And if I look at this, you can see there is grease and dirt that's on there. So I'm going to keep going. I'm going to get a new rag, and I'm going to come in here and maybe do one more round of this. And we're going to make sure, take the dry portion of this, and it's looking pretty clean. So that now I have the grease off this area. What we're going to do is come in and wet abrade that area. And to wet abrade it, we're going to use an abrasive. Now, this is the kind of abrasive we're going to be using. It's a cloth back material that has a garnet material on here of a certain particle size. This is 400 grit. The manufacturer wants us to start with 320 and then go to 400 grit. So we're going to do 2 stages of 320. We're going to do a wet abrade with 320, a dry abrade, and then we're going to go to a dry abrade with the 400. So when you get in lab, they may have given you a piece. What the TAs are going to do is rip off a section that's so big. They're going to write the grit size on there, and you're going to have a little piece of 400 or maybe a piece of 320. Okay. The other thing is, we're probably not going to use this all the way up. So we have a yellow box over here that typically, when you get done, put them in here. And if it's half used, maybe somebody can use this for a next project, and we can get all the use out of that abrasive. Now then, what is the grit size of the abrasive? The numbers, the 400, the 320. I've got an example set of sheaves here. These are not the ones that's going to produce the 320 or anything, but this is just for demonstration of understanding the difference in garnet size. For example, this screen on this sheave has a very coarse spacing, and it produces particle sizes, lets particles out of here at basically 137 thousandths of an inch. Okay, if I was to go to maybe one that's a little bit finer down here than the previous one, this one is going to let particles that are 78 thousandths in size fall through. So I could keep adding finer and finer, and this one's going down to about 30 thousandths screens on here until I get down to maybe about a 5 thousandths size particle that comes down through some of these. I could basically put my rough garnet that's been crushed and broken up into here, shake it, and it will go down through here, and the smaller particles will stop down here, the larger particles up here, and I can pull it off now, and that is going to dictate the size of the particles I'm going to have. So the higher the number, the smaller the particle size. So a 400 grit is going to be a finer abrasive than a 320. 320 is going to be for coarse operations and what we're doing here in the lab. Now, if you're doing something for senior design and you've got some really nasty steel and stuff, you may need to start with a 120, go to 220, then 320, and then 400. But most of the materials we deal with in this class are 6061 T6 extruded aluminum, and they're going to have a pretty nice surface. Again, we got all the oils off of here. Now we need to come in here, and you can see there's scratches and marks in the material. We need to prep that surface for a good adhesion of that strain gauge, because we're going to be measuring micro volts and amps, very small measurements. So we need really good adhesion to that material. So we now have our material degreased. I'm going to take the 320 grit, and again, you may have the nice bottle of isopropyl or the little pop-up. Just put some on your part here. Now this is going to evaporate fairly quick. I'm going to just start, and I'm going to go until I get the area prepped and I think it looks good. And that's going to be my wet abrade. Now what's going to happen is, over time, this chemical is going to evaporate off. If you don't have the time for the chemical to evaporate off, just take a rag, wipe that off, and it's going to dry even faster. So that looks good. You can kind of see I've got that area really prepped, got the major scratches out. Now I'm going to go, for me, I like to go in a linear pattern and remove those previous marks on there to know as I dry abrade that I got them off. Okay, so I'm using the other ones as a tell sign that, hey, you got to this layer with wet abrade. Now let's do a linear pattern with 320, and this is also going to be in the direction that I anticipate the stress to be on. So we're coming in and dry abrading that area with 320. We have now dry abraded that. So if I wanted to take a rag, for example, and wipe that off, I can see the difference in that surface, making a nice linear pattern. It's looking really good. At this point, we're going to move up to 400 and dry abrade with it. Now again, you're removing oxides and all that kind of stuff. Aluminum is known as a self-healing material, and that's what's nice is it creates a passive film called an oxide layer that keeps it from corroding. So as we do this, we're actually putting a lot of that oxide layer off, and we're exposing it to more of the base material. The longer this sits, that oxide layer is going to build up. So don't do this and then an hour later try and put your gauge on. We want to do this fairly smartly. Okay, so at this point we've got this area degreased, we wet braided, dry braided, and came in and it's ready for mounting. Now where are we going to mount that strain gauge on there? One of the things I want to look at is, again, this is an enclosed package for these gauges I have up here. I have an alignment line on the grid. I'm probably going to want to put an alignment line on my part. And to do that, what you're going to do is take a straight edge or something that indicates where you want that. So if I was wanting to measure the location of this from the end of the beam down on the other side, I could come in here and lay it out. I'm going to come in here with a number 2 pencil, the lead out, and I'm just kind of rotating and rubbing the lead on there. Don't do it with the metal piece of the pencil, just the lead. Okay, and what we're doing is we're not scratching a line, we're burnishing a line on there. That lead has a certain hardness, and if I take this rag, and I can see I still have lead on there, so maybe I want to come in here with the isopropyl again, get some of it up, and come in here and wipe this off. There we go. I've now wiped that lead off, but if I get it in the light just right, with my eyes, I can see that line ever so slightly. It may not be showing up for you, but I can see that line, and I know that's where I'm going to put my strain gauges, on that burnished line there. So at this point, we're done with this area. What you need to do is clean up the area, collect all your trash. You're going to take it to the trash. Any abrasives that are half used, put in the yellow bucket. Go ahead and close up your chemicals and put everything back like you found it. And let's go mount our strain gauge on this. So this session we're going to be taking a strain gauge from a packet like this, and this packet is going to talk to us about this strain gauge in terms of, this is an encapsulated strain gauge. It measures 120 ohms plus or minus 0.4%. It has the gauge factors on here, which is 2.04 plus or minus 0.5%. Those are two numbers we need to have there. Now, if for some reason you guys ever do something in senior design that's temperature based, then you're going to need to compensate for temperatures down here on the different factors. So we're going to be using the original gauge factor here of 2.04 in our experiments down there. So we need to remember those numbers that we had from the pouch when we mounted these on. So you might update your lab sheet there. Now you're going to be issued probably a couple of these. You don't want to get these out. These are in a little Mylar container, and we want to keep these nice and clean till the time comes. Now at this point you should have practiced soldering, and the TA is now going to issue your strain gauges. The other thing you should have done is already cleaned your metal and had your burnish line where you're going to want to have your strain gauge mounted. And this sample just came directly over, so the next thing I need to do is come in and clean this up and get it ready to glue on here. One of the things I want to point out is probably want to be gluing this on and letting the glue set while we go practice doing some soldering down the road. So let's talk about how to get this ready. Again, we have our isopropyl alcohol with our little pump here. We're going to have these nice little chem wipes right here. We can take some of these, and what I'm going to do is come in here and get this wet again. And now when I do this, I'm probably going to want to just clean that area with this originally, and this is just my initial clean. This is going to evaporate off fairly quick, and I can see if I get in the light just right where my line was. And what I'm doing is looking at the towel, and it was pretty clean, so I didn't introduce any more contaminant. Be sure to wash your hands, clean this beam before you come over to the station. We want this to be a real clean application. Now once you've used this is trash. We're going to discard that. Okay? We're going to get another clean chem wipe, and what we're going to do here is use conditioner prep. And this is already dried off. I'm going to put some conditioner prep on there. And when you do this, you only want to wipe where that's going to be going on at. Okay? I don't want to wipe over here and introduce dirt back in there. I want to come in and condition that area that I'm in. And you notice I am getting some contaminant on here. Okay? This is doing a further cleaning. So I'm using a clean section of the rag and still getting some contaminant. You're going to do this till you get it clean. Okay? So I'm going to go in there and keep going until I get this clean. And see if I can get a dry cloth, and it's looking clean. The next thing I want to do is probably put a little bit down here on this glass and clean it. Okay, this is just a nice little area. I'm going to use a nice clean section of the cloth that hadn't been used, and that's where I'm going to be putting my strain gauge down later as we get ready to prep it. So I need to prep the part, prep this. We just did conditioner. Okay, that's the one with the red lid. The next thing we got to do is come in here with our neutralizer. Now, one of the things that helps on this neutralizer is to put a little bit on the part and then take a clean Q-tip, and where that gauge is going to go, come in there and wipe. Okay, go back and forth, and I find moving the Q-tip back and forth is a great tool to do that with, and it's nice and clean. If it comes up that it is dirty, you need to keep cleaning. Okay, so I'm going to clean that. I'm going to come in here and just put a little bit of this on here and do a final wipe, because I noticed that Q-tip sometimes will put a little bit of material from the Q-tip on there. So I'm going to come in here and put a little bit there, do a final neutralize of that area and a final neutralizing of that area. Now at this point, they're going to dry. Okay, I'm going to let them dry and dry clean. Everything looks good. I'm happy. Got my area, lay down area, and I've got my gauge area clean. My hands are clean. And what I'm going to do is come in here and grab one of my strain gauges out. Now, this is going to open up right here, and what you want to do is use the tweezers real careful like, and you're going to reach in and only grab the strain gauge right there next to the pad. Do not grab it up in here in the gauge area. You will damage this. I am going to lay this on the clean area that I prepped. Remember, you need to have the copper side up, not this side. Okay, I'm going to lay that on there. And then I'm going to take the special tape I talked about. This tape is for mounting our strain gauge. We've tried all different tapes, and yes, this is an expensive tape from the same company that we get all the chemicals from Micro Measurements, and I highly recommend this tape. So don't use this tape for just general taping purposes. What we're going to use this tape for is taping to our strain gauge, because it won't let the super glue stick to it. So what we're going to do is pull out about a couple of inches here, a piece about 1.5 to 2 inches long, and I'm going to cut that. Okay, so now I have my tape cut. What I'm going to do is come in here, and that center portion is nice and clean. I'm going to come in here and just kind of slowly put pressure on there so I can get that gauge onto there. Now it's mounted. I don't need to press real hard on this. Again, this is where I cleaned, and I'm going to go up here to where my mark is going to be. What I need to do now is doing a real cute angle, slightly pull and lift, okay? And I'm going to lift that strain gauge up off of that part, okay? So I've now lifted that strain gauge off. Now I'm going to line this strain gauge with my burnish mark in the center of this beam where I want it to be. And again, I'm going to kind of put some light pressure down here, and it's laying on my burnish mark, which is going right here, which is aligning with my grid pattern on the strain gauge. And then what I'm going to do is slowly, again, lift up here until I expose about 1/4 inch of that gauge. Okay, I'm going to put a drop of glue on here, and I'm going to glue this dull surface, not the surface with the exposed pads. That's where I'm going to be soldering to. I'm going to glue that to the metal itself. What I recommend next is using the catalyst on this. And the catalyst, you want to use as little bit as you can. It's going to come off in this bottle right here, and it has this nice little wick here. I recommend getting a good amount of it off, and then just come in here and put this on here and just wipe up. And I've got a nice sheen across there. Just a very light coating of catalyst. It does not take a lot. Okay, if you get a lot on there, you're probably going to have to let it dry off, and we may have lost our strain gauge. The other thing that we have here is the adhesive itself is basically super glue, and we're going to open this up, and this reacts with moisture, so we always want to keep this thing closed. Point of safety, do not get this on your hands. So when we get ready to do this, I like to have a clean wipe and fold it up into a nice little square that I'm going to use to push the glue back down on my strain gauge here. So what I'm going to do is come in here and open this up. I'm going to put a drop of super glue basically, right there, and go ahead and cap this. And I'm going to grab this tape, and what I'm going to do is push with the towel, and I'm going to let pressure, I'm just going to slowly walk that gauge down, and that glue is going to run up the full length of that gauge. And I'm watching it with my eye that I can see that glue going up. And so what I'm going to do is come in here and put this on, and you want to make sure you keep a rag between you and the part, and you're going to hold that on there for about 2 minutes with good pressure on there. Okay, once we get that off, we're going to let it sit for another 3 minutes, and then we can remove the tape. I prefer even giving it a few extra minutes just to make sure I don't have any problems. So again, you probably want to have a watch, time it, and just have patience and let the glue dry. Now, instead of pulling it up like we did the other way, we're actually going to lift it back on itself. So I'm just going to attach it to my finger here and kind of pull back that tape. And this is going to minimize the stresses on that strain gauge. Okay, so you can see I'm coming in there and pulling that off. It's leaving the strain gauge firmly attached. All right, so now I can go ahead and remove the rest of the tape. At this point, we want to come back in here and inspect the adhesion of the gauge to that part. What we're looking for is that the corners are not lifting. Now, I'm not trying not to touch the gauge in any of this. I want to make sure I didn't ever damage the tops of this gauge and that I've got my pad still exposed. So at this point, this is ready to be soldered. So once you get confident in tenting the wire, tenting the pads, and soldering the wires on, you're going to be ready to come in here and solder this on. We're ready to come in here and prep this for tenting. And what we're going to do is come in here and cover the gauge in about 20% of those pads right there. And those are exposed. And that's, again, with our masking tape or painter's tape will work just fine. Now, before I fire the iron up and get ready to solder, I need to prep my wires. And again, we're dealing with probably about a 30 gauge twisted pair of wires here. I've got a long enough wire that I can reach from the gauge to the test indicators, and it's going to have the wires wrapped around here. So basically these are twisted, and if I just untwist a little bit right there, I can get exposure to that wire. Now, what we're going to learn is there's 3 wires and 2 pads. What are we going to do there? We are going to basically connect the white and the black wires together to one pad and a red wire to the other pad. Now, these strain gauges do not have polarity. That means that they don't have a positive and a negative portion of there. They're just basically, it doesn't really matter. It's just preference. I like to be organized and do everything in the same manner. There is a technical reason for having the extra 2 wires for compensation, and we have to connect to a bridge, and we want to have the same current capabilities. And so on the bridge types, typically we have to have 2 wires, and we pull those off that one side of the gauge. Okay, so we've come in and we've now got that exposed. So what we're going to do is grab our wire, and this is going to be 30 gauge wire. We're going to make sure it has long enough length to go from one end to the gauge to the test unit. What we're going to do is unbraid just a little portion of this right here of that wire, so we have those unbraided. You notice we have 3 wires and 2 pads. The strain gauge, again, is not going to have polarity, so it doesn't matter which sides the wires go on. But I typically, when I'm looking at the gauge, I typically put the red wire to the left, and so if I'm looking at the gauge here, the left would be the top side up here, and then the white and the black are going to be braided together going to the other pad. And if I'm looking at the gauge like this, typically I will put the red wire on the left and the white and the black on the right. Okay, it doesn't matter. There's no polarity. But what we need to do is come in here and prep these wires. Now you're going, why is there 3 wires and we only have 2 connections? Most of our connections require a quarter or a Wheatstone bridge. We're going to need 3 wires to make that connection. And to keep current and everything consistent, we need a conductor all the way from here to the test unit, so we're not introducing any variability. The other thing is, when you're thinking about these wires, you want to make sure you have them cut where the wires are all the same length, and we don't have longer and shorter wires being mixed in here. We want to keep everything apples and apples here. So what we're going to do is come in here and we're going to use our tools. Again, we have different cutters that we have. We can nip the wires to length using these, or we can come in here and use our wire strippers for stripping these. Now again, we need to do about a 1/16 of an inch, so I usually do it a little proud. What do I mean by proud? A little bit longer than a 1/16 of an inch, because I'm going to tent these wires and I'm going to take them to length. And it's also easier to work with these black and white wires, braiding them, if I do them just a little bit longer. Okay, so I'm going to come in here and strip the wires off. Now these stripping off, I don't have to worry about the wires shooting off because it always stays on this. Where if I'm using this tool, it could shoot the wires away from me, so I'd always want to aim downward. What I'm going to do is grab these black and whites, and again, these are braided wires. I'm going to start twisting them, putting them together. I'm going to twist the wire back on itself there, and I have those really nice and twisted up there. Now again, I'm going to use the larger wire right here, the 0.8 millimeter or the 32 thousandths in diameter, to do my tinting. So you can see the smoke's going there. I'm going to come in here and just tint that wire so slightly, and tint these other ones down here. We've got our thinner wire. I'm using the 22 thousandths in diameter wire, the thinner wire here. I'm going to tint up my iron. And I've got my two pads tinted with solder. Okay, so again, remember, put the solder down, put the iron on top, and just let it hit. You don't want to put a lot of heat into there. Okay, and that's looking good. What I want to do now is come in here, and I'm going to nip these wires to length, to the 16th that we talked about. Okay, and I'm going to put these wires right here on top of my gauge where they need to be. Okay. Now, let me move some tools off here and bring this up so you can kind of look at this. And when we look at this, the things I'm looking for is I want to make sure that here I can kind of move them back a little bit. So I'm kind of pushing it back a little bit in there. I want to make sure the insulation is protecting the wire from touching the substrate, the base material here. I want to make sure that my solder joint, my wire, is on top of my tinted portion of the pads, which I have both of them ready right there. So all I got to do is put my solder on here, float those two together, and we're going to be in business. So I'm going to go ahead and lay that down here. My iron is still hot. I'm going to clean the tip off. I'm going to come in here and retint the solder iron. And I'm going to put it on here, put the solder on top, and go 1, 2, 1, 2, and those are now going to be soldered together. And that's all it takes to solder those. So we'll take it apart here and inspect it. We don't have solder going from this terminal, this pad, to this one. There's no connection. No solder or metal is connecting down here, and it looks like they're nice clean solders. You can see the exposed pads that we had left at 25%. We didn't get any heat into the gauge, and so this is looking good. What I'm going to do is hold my finger down there, bend these wires where I have that little stress union in there. I'm going to put these wires down on here and tighten this up. Okay, and what that does is if somebody pulls on this wire, they're going to put stress on this here instead of on the strain gauge itself. And so that's a good way to kind of tape those down at this point. Now sometimes we'll take a hot glue gun and we'll hot glue gun those, and that's not going to cause any more resistance or any issue for us. What we're ready for at this point is to go test and see if this strain gauge is properly installed using a test indicator. And we're going to be talking about how to inspect our install and make sure we didn't do anything wrong. We did a visual inspection earlier as we installed this, and we came in here and tinted the 3 wires. And what we're going to use is this 1300 model gauge insulation taster. Basically, this is a high-tech ohm meter, and it's going to be a lot more sensitive in terms of measuring our install. Now we have 3 wires, and on this one what we're going to do is come up here and loosen this up and make sure you're tightening down on the section that you tinted, the exposed wire on the red. We're going to take the black on this one, and we're going to go into the black lead connection, and then we're going to take the white, and since this is a 120 ohm plus or minus 0.4, and remember our gauge factor here of 2.04 plus or minus half a percent, we're going to go ahead and hook that in here to the 120 on the white. There's a 320, and that's for a 320 ohm down here. One last connection that we need to have is we need to know if we have any shorts. So we're going to hook a ground to here, and we're going to hook a ground to our part using the alligator clip. Okay, so now that we've got everything hooked up, let's look at this box. If we come in here and hit the battery button, it's going over here pegging out on the meter. That means we have battery. If the battery's low, we need to replace the batteries. we have a 5% and a 1% scale. If I push here, I can barely see it move, and it's not as easy to read, but if I go to the 1%, I can see that I'm at 0.2%. That's within tolerance of our strain gauge, so we're good there. The next thing I need to do is come here and check out the ohms, and when I hit that, that's going to come over here and read about 120 ohms. So that's the ohms of our unit. And then we have to meg this out. And this is a foiled type encapsulated strain gauges that we're going to be using in class. So we'd like to see around 20K on this. So if I push this, we're up around 20K when I first got it on there. Okay. And so this is going to be a good install. And we're happy to take it to our next stage and go do testing with this.